Today we will discuss about working and voltage build-up process in DC generator. A DC generator, also known as a dynamo or a direct current generator, is a device that converts mechanical energy into electrical energy. It operates on the principle of electromagnetic induction, where the relative motion between a magnetic field and a conductor generates an electromotive force, EMF, or voltage. Working principle. The basic components of a DC generator include a magnetic field, a rotating armature, and a commutator with brushes. The magnetic field is typically created by permanent magnets or electromagnets. The armature consists of a set of conductors arranged in the form of a closed loop or coil. When the armature rotates within the magnetic field, the relative motion induces an EMF across the conductors. According to Faraday's law of electromagnetic induction, the magnitude of the induced voltage is proportional to the rate of change of magnetic flux through the loop. This induced voltage causes a flow of current in the armature conductors. Voltage buildup process. Initially, when a DC generator is started, it has no output voltage. The voltage buildup process is necessary to establish a magnetic field and generate a steady output voltage. Here's a step-by-step explanation of the voltage buildup process in a DC generator. Field excitation. The field windings, which produce the magnetic field, are connected to an external source of DC power called the exciter. This exciter provides the initial magnetic field needed for voltage generation. Initial rotation. The prime mover, such as a turbine or an engine, is used to rotate the armature. As the armature starts rotating, the relative motion between the magnetic field and the armature conductors induces a small EMF across the conductors. Induced current. The small induced EMF causes a small current to flow through the armature conductors. This current passes through the field windings as well. Commutator action. The commutator, which is a cylindrical arrangement of insulated metal segments, is connected to the armature conductors. It ensures that the direction of the current in the armature conductors changes as they rotate, resulting in a unidirectional current flow in the external circuit. Magnetic field strengthening. The small current passing through the field windings creates a magnetic field. This magnetic field interacts with the magnetic field from the permanent magnets or electromagnets to strengthen the overall magnetic field. Self-excitation. As the magnetic field strengthens, the induced EMF across the armature conductors also increases. This higher induced voltage generates a larger current through the field windings, further strengthening the magnetic field. This positive feedback process continues until the magnetic field reaches a steady state. Steady state voltage. Once the magnetic field reaches a steady state, the induced EMF across the armature conductors stabilizes, and a constant voltage is produced at the output terminals of the DC generator. The voltage buildup process ensures that the generator can maintain a steady output voltage as long as the prime mover continues to rotate the armature and the exciter supplies the necessary excitation current to the field windings. Thanks for watching.